Hello everyone, welcome to the sixth session on oil hydraulics and pneumatics, and in this specific session we will be continuing with the fluid power symbols. We are going to cover up two major set of symbols. Very first are the pumps and compressor, and second are the actuators. So let us start with this session. So the very first, we are going to understand the symbols of the hydraulic pumps. But what are basically the hydraulic pumps? Let us understand. The hydraulic pumps, or say simply pumps, are actually the device that converts mechanical energy to the hydraulic energy. The mechanical energy will be received with the help of the electric motor or any kind of motor or the IC engine to the pump. As you can observe, this is the symbol of the pump. These two arrows represents the transmission of the mechanical energy to the pump, which is coming inside, and that mechanical energy will be converted into the hydraulic energy, and to do that specific conversion these pumps are used. So as you can observe, this is the circular symbol. In the previous video we explained that this specific circle will represent the energy conversion element. So energy is coming as a mechanical one, and the energy that is getting output is actually the hydraulic one. So energy conversion is there. Second thing that we understood is this specific arrow actually represents the hydraulic component, because this is a completely blocked arrow. So as this is the hydraulic component, this is known as the pump. But if this arrow is the hollow arrow like this is the similar symbol, but this is having the hollow arrow. So this will be a compressor, because it is actually compressing the air. It is doing the similar thing, conversion of mechanical energy into the hydraulic energy, or say fluid energy, but it is actually transmitting that energy into the air. Okay, so this is known as the compressor, because it is transmitting energy to the air or gas, and this one is known as the pump, because it is transmitting energy to the liquid. Okay, now over here, as you can observe, the flow is only in one direction. Whatever the arrow shows, this is the direction of the flow. So arrow is showing only one direction of the flow. That's why this is known as the one directional, or say monodirectional flow, and we will be saying this is the monodirection pump. Second thing, if you observe, there is no 45-degree arrow available that we saw in the previous video. So this is a fixed displacement pump, which is a one directional flow. So we can say that this is a fixed displacement one directional flow pump. Now if the arrow is available like this, if there is an arrow, this specific pump will be known as the single directional variable displacement pump, because the pump displacement can be varied. Okay, now if you observe over here, this specific symbol is of the hydraulic, and this is also available at the downward sides, which shows that the pump can actually work in the downward direction also and in the upward direction also. That means that this specific pump is a bidirectional flow pump. So if we want to show the symbol of the bidirectional fixed displacement pump, then we need to draw this specific symbol. If we want to draw the symbol of the bidirectional variable displacement pump, in that specific case we need to draw this specific symbol. Clear? Now let us go towards the pneumatic part of the same thing. As this was the liquid in which the flow was, or say power was transmitted, this is known as the pump. But as over here the power is transmitted to the air is getting compressed, that's why this component is known as the compressor, as we saw previously. Over here, this one is the monodirectional fixed displacement compressor, and if I draw the arrow over here, this is a monodirection variable displacement compressor. So you can actually vary the displacement in this specific component. Now the reverse of the pump or compressor will be known as the motor. The function of the pump was to convert mechanical energy into the hydraulic energy. The pump was transmitting the mechanical energy into the hydraulic energy. So the direction was something like this, or direction was something like this. Okay, but if the reverse function is to be performed. Like if you want to convert hydraulic energy into the mechanical energy, like this, the direction is like this. In that case, you need to draw this specific symbol. What is happening? The flow is coming something like this and the energy is being transferred like this. So this specific symbol, the reverse arrow, shows the hydraulic motor. This specific symbol is for the hydraulics. So this is known as the hydraulic motor. So the specific conversion element will receive energy as a hydraulic energy and it will convert that energy into the mechanical energy and it will be transmitted through this specific shaft. This is the shaft which is available, okay, and the remaining fluid will go ahead. Completed. Now this specific one is a monodirectional flow or one directional flow, and this is the fixed displacement one, and if you draw the 45-degree arrow, it will become a variable displacement one. Simple. Secondly, if it is a bidirectional flow, that means if you flow fluid in this specific direction, it will convert that fluid energy into the mechanical energy. Even if you convert that fluid, or say if you flow the fluid in this specific direction, upward direction, even then it will convert that energy into the mechanical energy. So this is a bidirectional flow. This is the fixed displacement bidirectional flow motor, okay. And if you draw the 45-degree arrow something like this, this becomes the variable displacement bidirectional motor. Clear? So if you observe these symbols, this was the pump in which the flow of energy was something like this. The mechanical energy coming from here will be transmitted like this. So the arrow was indicating in this direction, and in the motor the direction is reverse. The fluid is coming into the motor, it is getting transferred, or say fluid energy is getting transferred into the mechanical energy. So the flow is like this, so arrow is in the reverse direction. Mindset clear? So this is known as the hydraulic motor. Now let us understand the last one. As I told you, whenever you see the semicircular part, the semicircular part is what? The limited rotation actuator, okay. So these hydraulic motors are nothing but they are one kind of actuator, they are the rotary actuators, okay. So this is a limited rotation actuator. Now what will happen over here? This arrow represents that fluid is coming in this direction and it is converted into the mechanical energy, as there are two arrows available which shows some solid connection, okay. So the fluid is transmitted over here, the fluid is transmitting all the energy and it is getting converted into mechanical energy. Now over here this will be the limited rotational energy. So it will not rotate complete 360 degree, it will just give you the rotation in a specific angle, okay. And if you want to vary this specific angle, or say if you want to change the displacement, you have to use this specific arrow. So this specific arrow represents the variable displacement limited rotation motor. Mindset clear? So this is all about the hydraulic motors. Now let us understand what is the option available in the pneumatic side for the same one. The option is known as the air motor, okay. Now the similar thing is happening over here. The pressurized air is coming inside. This energy conversion component will convert that pressurized air energy into the mechanical energy. It will be transferred in this specific direction. This is the shaft connection. So this is known as the air motor. This is a fixed displacement one directional air motor. This is the variable displacement one directional air motor. The same thing will happen over here. This is a bidirectional, that means even the airflow is coming from here or here, it will convert both sided flow into the mechanical energy and it will be getting transmitted from this specific shaft. This is the fixed displacement two directional air motor and this is the variable displacement two directional air motor. So this is what the option available in the pneumatic side. Now the next symbol is actually the combination of both. If we are having pump and motor both, so if we are having any component that can actually do both the work, the component that can convert mechanical energy into the hydraulic energy also, and if there is an hydraulic energy coming inside, it can also be converted into mechanical energy. So if any component can do both the work at the same time, or say on the alternative times, that specific component can be represented something like this. This is the component which can act as a motor also, which can act as a pump also. And over here, as you can see, this specific arrow that is available over here actually represents the pump, because the arrow is showing outward direction. So mechanical energy will be transmitted into the hydraulic energy and it will getting transferred in this direction. This downward arrow will show this specific direction. So this is an bidirectional pump. This is a bidirectional pump. Now over here, this specific arrow shows the reverse, the motor. That means the energy is coming from here and it is getting converted into mechanical energy. So this is the motor symbol. Okay. So this is something that actually act as a motor and pump also. So this is the symbol: fixed displacement pump or motor, or variable displacement pump or motor. Okay. So this is the convertible element. So this is all about the pumps and the rotary actuators. Pumps and the rotary actuator. Motor are known as the rotary actuators. Now let us talk about the prime movers. Now prime movers are what? That actually provides the mechanical energy to the pump or the compressor. Prime movers are the devices that actually generates mechanical energy and provide that mechanical energy to the pump or compressor. The first element is the electric motor. So electric motor will take the electricity from outside and it will convert that electricity into mechanical energy, and that will be transferred through the shaft into the pump. So this is one of the prime mover. The second prime mover can be the internal combustion engine. Internal combustion engine will convert the chemical energy of the fuel into the mechanical energy. The symbol of the internal combustion engine is this specific rectangle, and the symbol of the electric motor, as it is the motor, the symbol will be a circle inside which we need to write down M. So this is the symbol of the electric motor. Okay. Then after they were the prime movers. We saw the actuator, rotary actuator also. Now we will be seeing the linear actuators. They are also known as the cylinders. So very first and very basic component is the single acting cylinder. Now this is the symbol of the single acting cylinder. As you can see, the outer section will represent the cylinder itself, and the internal block which is available over here, which will represent the piston, and this is the shaft output of this whole cylinder. Now this line which is available over here, it actually shows the hydraulic fluid input or pneumatic fluid input. So what will happen whenever the system receives the pressure, the fluid will get inserted in this specific area and this piston will move in the right direction. So ultimately this specific shaft will move outside. Okay, so it will look something like this in actual, and if you observe the cross section, it will look something like this. So this is the shaft or piston rod which is available. This is actually the piston. This is the outer cylinder or barrel which is available. Now fluid will be inserted from here. The fluid will be inserted. The piston will pressurize. The piston will move in this specific direction. So due to that, the piston rod will move outside. Now over here, the problem with the single acting cylinder is that it can move only in the one direction only, one side only. If you want to move it in the reverse direction, that means once you have moved into the right side, if you want to move towards the left side, you have to manually press that piston rod. So this is the problem with the single acting cylinder, or many times there is a weight that is kept over here if it is a vertical cylinder. So this is how the cylinder will actually look like. Okay. The second symbol is the single acting cylinder with the spring return mechanism. So what will happen to actually come out with this limitation? The spring is added to this specific cylinder. So what will happen whenever we need to move this cylinder piston rod at the right hand side, the fluid will come over here, pressurized fluid will come inside this specific cylinder and it will move the whole piston in the right side, and once the fluid pressure is removed, the spring mechanism will automatically move this specific piston into its actual position. Let me show you with one animation. This is the animation. As you can observe, the pressurized flow is coming from here and it is moving this piston in the right side. Once the flow is actually pressure is actually removed, the piston will return itself with the help of the spring force. So this is what happens with the single acting with the spring return mechanism. Clear? The third one is the double acting cylinder with the single piston rod. Now this specific piston is having actually two inputs. So one pressure line is available over here, second pressure line is available over here. So whenever you want to move piston into right direction, or say if you want to move piston rod into right direction, the pressure line will be activated, will be this one. The pressure line that is getting activated will be this one, and the fluid pressure will come over here, which will pressurize this area. So the piston will move in the right direction. Now once you are done with this one, just increase the pressure of this pressure line, or say activate this pressure line. What will happen? This area will be filled with pressure and the piston rod will move in the left direction. Clear? Let me just show you with the help of one animation. As you can observe, this is the similar representation and this pressure is coming from here, pressurizing this area, piston will move. Once done, the second line will be activated, which will actually help to return this specific piston. Okay, so this is how the double acting cylinder with the single piston rod will work. Now let us check out the next category, the double acting cylinder with the double piston rods. Now what do you understand by double piston rods? Double piston rods are basically nothing. One piston is available and at the both the sides we will be having the piston rods. Let me just show you the animation so you will be able to understand it in a similar way. So this is the animation. As you can observe, there are two piston rods available with the single piston. So what will happen? Actually there are two works that can be done with the help of one mechanism. Okay, so this is how the double acting cylinder with the double piston rod will work. This is the symbolic representation of this one. The second one is the cylinder with the end cushioning. Now let us understand first what is the cushioning. Let us understand very basic way. The cushioning is basically needed to lower down the speed of the cylinder before it reaches at the end gap. What will happen? There will be the heavy impact at the end of the stroke. So if the cylinder reaches at the end, there will be a heavy impact. So to soft down that specific impact, the cushioning is used. So what will happen? It will lower the speed of the piston and it will help to reduce the stress on the components which are available on the cylinder. Okay. So basically cushioning will be represented something like this. This is a small rectangular block which will represent the cushioning. So by this what will happen? It will just represented something like this. As you can observe, at the end the cylinder is getting smoother end. Okay, the cylinder is getting slow down. This is basically happening due to the cushioning which is provided over here, and this cushioning is actually the adjustable one. As you can observe, this is the variable symbol. Okay, so this specific variable symbol is representing the adjustable cushioning. So over here, if you observe, there is a screw available on the top which will help to actually adjust this specific cushioning by actually losing and or fitting down. Okay, so this is the cylinder with the single cushioning. If you want the same thing at both the ends, in that case you have to provide the double cushioning. That means you have to provide this symbol. This is the first cushioning, this is the second cushioning, and if it is the fixed one, then do not add this arrow. If it is the adjustable one, you should add this specific arrow. Okay, and the last one is the telescopic cylinder. Now telescopic cylinder is actually the arrangement of the multiple cylinders. This is the first cylinder. This is the piston actually, which will act as a piston for the upward cylinder, but it will act as a cylinder for the internal piston. Okay, so there is a multiple piston cylinder mechanism available inside. Let me just show you with the help of an animation. So this is the complete arrangement. As you can observe, once the pressure comes, the first cylinder will be there. In that specific one, the second one will act as a piston for the first cylinder. Further, as the pressure increase, the second will come out, the third will come out, and finally it will look something like this. Okay, so this is how the telescopic part will work. It will act like a telescope. Okay, so this is how the telescopic cylinder will work. So these are the varieties of the you can say cylinders available as a linear actuator. Okay, so these are the linear actuator, also known as the piston cylinder mechanism. So this is the end of this specific lecture. Keep learning. Have a good day.